There's a cathedral in Rome that has been standing for almost 2,000 years. No steel frame, no rebar, no maintenance crew replacing crumbling sections every few decades. Just stone, stacked on stone, quietly outlasting empires, wars, plagues, and entire civilizations that rose and fell around it while it just kept standing there. Now think about a parking garage, maybe one near where you live. Built 40 years ago. Already cracking. Already patched with ugly gray concrete filler. Already scheduled for demolition sooner than anyone wants to admit. Some of these structures don't even make it to 50 years before engineers start seriously discussing tearing them down completely and starting over. By the end of this, you'll understand exactly why the most advanced civilization in human history builds things that fall apart faster than structures made by people who didn't even have iron tools, didn't have machinery, and didn't have modern engineering degrees. Because here's the part that should genuinely bother you. Every skyscraper you work in, every bridge you drive over, every parking structure you park in, it's all running on borrowed time by design. And it wasn't always like this. For most of human history, the entire point of building something big was that it would outlast you, your children, and their children too. Permanence used to be the whole goal. So what happened? Why did we walk away from a material that basically lasts forever? Let's start with the obvious answer. The one that feels right, but is only half the story. Speed and money. Stone is heavy. Unbelievably heavy. A single block used in ancient construction could weigh several tons, sometimes tens of thousands of pounds each. It's slow to cut out of the earth. It's brutal to transport across any real distance without modern machinery. Quarrying a single block could take a team of workers days of grinding, repetitive labor. Moving it into place, especially before machinery existed, could take weeks of coordinated effort, using nothing but ropes, wooden sleds, log rollers, and raw human muscle straining against gravity. If you wanted to build something enormous out of solid stone, you needed decades, sometimes centuries, and an almost unlimited labor force willing to dedicate entire lifetimes to a single structure they might never even see finished. Steel and concrete flip that equation completely. A skyscraper that would have taken 80 years to build in stone can now go up in 18 months. Concrete gets poured, steel gets bolted together, and a 40-story tower rises in the time it used to take just to finish laying the foundation of an old stone structure. Think of it like furniture. Building with stone is like carving a dining table out of a single solid block of oak by hand. It takes forever. It's exhausting, back-breaking work. But your great-great-grandchildren will still be eating dinner on that same table 100 years from now, without it so much as wobbling. Building with modern materials is like assembling flat-pack furniture from a box. It goes up in an afternoon with a few tools. It's cheap, it's convenient, and everyone involved quietly understands it's not built to last generations. It's built to last long enough, and not a day more. But speed alone doesn't explain everything. To really understand why stone got left behind, you have to understand how stone actually holds itself up in the first place. Because it works in a way that feels almost too simple to be real. Stone buildings survive almost entirely through one force: compression. That means weight pressing straight down, stone against stone, all the way down into the ground beneath the foundation. There's no stretching involved, no bending, no pulling, just pure downward pressure, transferred block by block, all the way to the earth. That's why ancient builders became obsessed with arches and domes. An arch takes the weight pushing down on it and redirects that force outward and downward through each individual stone in the curve, like a chain of people passing a heavy box down a line. Each person only holding a piece of the load for a moment before handing it off to the next person, never bearing the full weight alone. Picture stacking a pyramid out of sugar cubes on your kitchen table. As long as every cube is sitting directly on top of another, pushing straight down, the whole structure holds, no matter how tall you build it. Add another layer, and and it just keeps standing there, stable and quiet. But the second you try to make one cube stretch sideways, or bend without proper support underneath it, the entire thing collapses instantly, in a fraction of a second, with no warning at all. That's stone in a nutshell. Incredible under pressure. Completely helpless under tension. And that brings us to the moment that shouldn't make sense, but explains everything about why these buildings survive. By common sense, a material with zero ability to stretch, bend, or resist pulling forces should be the worst possible thing to build enormous structures with. One wrong stress in the wrong direction, and it should just shatter into a pile of rubble. And yet stone structures have outlived almost everything humans have built since then, by a margin of thousands of years in some remarkable cases. Here's the shouldn't work moment. Ancient engineers didn't fight stone's weakness. They designed entirely around it instead. Every wall was built thick enough, sometimes several feet thick at the base, that forces stayed compressive no matter what happened above. Every arch was shaped so that the load always pushed down and outward, never sideways, never pulling apart. They essentially removed tension from the equation completely. So the one thing stone couldn't handle never became a problem in the first place. It's not that they beat physics. They simply refused to fight a battle they knew they'd lose. Think of an old-fashioned phone book sitting on a shelf. Try ripping it in half with your bare hands. Nearly impossible, because that's a tension force, a pulling force, and paper resists that about as well as stone does, which is to say, barely at all. Now instead, try parking a 2-ton car directly on top of that same phone book, with the weight spread evenly across its surface. It won't budge an inch, because that's compression, straight downward pressure, and paper handles that surprisingly well. Same exact material, completely different outcome, all based entirely on the direction the force is being applied. That's the entire secret of ancient stone architecture, demonstrated with something sitting in your junk drawer. So if this system worked so reliably for thousands of years, why did we eventually abandon it? Because eventually, humans wanted something stone could never give them, no matter how cleverly it was arranged. Height, open interior space, speed of construction, and all three of those demands required a material that could handle tension, not just compression. Enter steel and reinforced concrete, the pairing that rewrote the rules entirely. Steel bends without snapping. It can be pulled, stretched, and twisted under enormous stress, and still hold its shape and keep doing its job reliably. Concrete on its own is strong under compression, almost as strong as stone in that specific regard, but it's genuinely terrible under tension. It cracks almost immediately when pulled or stretched even slightly. So engineers combined the two materials together. They poured wet concrete around steel rebar, creating a hybrid material that could resist both compression and tension at the same time, something neither material could accomplish alone, no matter how it was shaped or arranged. That single combination changed everything about what was structurally possible. Suddenly, you could build walls a fraction of the thickness of old stone walls and still hold up massive loads. You could span enormous open distances, hundreds of feet in some cases, without a single supporting arch underneath. You could stack floor after floor after floor, dozens of stories high into the sky, using a fraction of the material, a fraction of the labor, and a fraction of the time it once took to build something a tenth the size. But here's the trade-off almost nobody talks about, and it's a big one. That same rebar, the hidden steel skeleton that makes modern buildings possible in the first place, is also what quietly destroys them from the inside over time. Piece by piece, invisibly, steel rusts. And when steel rusts, it expands, sometimes swelling to several times its original volume as the metal corrodes. Buried inside solid concrete, that expanding rust has nowhere at all to go. So it pushes outward with tremendous force, cracking the surrounding concrete from within, invisibly, for years, sometimes decades, until chunks eventually start falling off entirely, and the damage finally becomes visible from the outside, often long after the real problem began. It's the exact same thing that happens when a nail rusts inside a piece of wood over time. At first, everything looks completely fine on the surface, no cause for concern at all. Then one day, months or years later, the wood suddenly splits apart along the exact line where that rusting metal has been quietly swelling the entire time, completely out of sight, until suddenly it isn't hidden anymore, and the crack is staring right back at you. That's not a flaw or a mistake in modern construction. That's the built-in cost of the trade we collectively made. We gave up near-eternal durability in direct exchange for height, speed, and open space. Most reinforced concrete structures today aren't even engineered to last forever in the first place. They're specifically designed for a lifespan of somewhere between 50 and 100 years. After that window eventually closes, the expectation, quietly built directly into the original blueprints from day one, is that the structure will need major repair or complete replacement. Compare that to a stone cathedral built with the genuine expectation that it would still be standing a full 1,000 years later, and you start to see just how differently we think about permanence now compared to builders working many centuries ago. It's the same difference between a cast iron skillet and a modern non-stick pan sitting in your kitchen cabinet. A cast iron skillet, cared for properly, can outlive the person who originally bought it, get passed down through a family, and still be cooking dinner 50 years later without a single issue. A non-stick pan is convenient. It's lightweight. It's cheap up front at the store, and everyone buying one already knows going in that they'll be replacing it in just a few years without giving it a second thought. Stone was the cast iron skillet of architecture. Concrete and steel became the non-stick pan of architecture. Mass-produced, efficient, and never really meant to be permanent in the first place. So the honest answer to why we stopped building with stone isn't that we found something objectively better in every single sense. It's that we found something faster, cheaper, and taller. And we quietly accepted, as an entire industry and as a society, that it would also be something temporary by design. And that trade-off isn't just dusty history sitting in a textbook somewhere. It's actively happening right now, underneath your feet and directly above your head, inside almost every modern structure around you, every single day, all around the world. Because if concrete is slowly cracking apart from the inside due to rusting steel, all across the entire world right now, in bridges people drive over every single day without giving it a second thought, in parking garages people park in without hesitation, in the foundations of skyscrapers where people work 40 stories up in the air, then the real question isn't why we stopped building with stone. It's how many of the structures we trust the absolute most, right now, today, are already quietly failing from the inside out, decades ahead of schedule, completely invisible to the naked eye, without anyone noticing a thing, until it's already far too late to fix. And that's exactly what we're breaking down next.